For our next worksheet, we're going to look at complex fractions, order of operations, and then we're going to start looking at mixed numbers. So for topic one, we're going to simplify something called complex fractions. I can tell you that you can live a very full life and not really have to use complex fractions, but it's part of our curriculum, so I want to at least show you what this means. If you were to go into a higher level algebra class, this could come up when you're dealing with complex rational expressions. But for us, we're just going to just touch our toe into it. We're not going to do much, okay? So definition, a fraction whose numerator or denominator or both numerator and denominator contain fractions is called a complex fraction, okay? So it's like a fraction where the numerator and denominator are made up of fractions or the sum or difference of fractions. So there's a way to simplify these. What you could do is add or subtract in your numerator and then divide, but that becomes kind of a lengthy process. So if you do have one of these complex fractions, there's kind of like a shortcut way that you could simplify this. And the way we do that is we look at all of the interior fractions and we find the LCD for those. And then we multiply all of the numerators, all of the interior fractions, so the numerator and the denominator by this LCD, and things simplify really, really nicely. Okay, so let's go ahead and look at an example. This is not a big part of what you need to know, but it is something that I wanted to just kind of quickly show you. So example one says simplify each complex fraction. So when I'm talking about interior fractions, I can see that I have one big fraction, but the numerator is made up of the sum of two fractions. The denominator is made up of the difference of two fractions. So those pieces that make up that sum and difference, those four fractions, those are the interior fractions. So there we go. So looking here, we've got denominators of 2, 6, 4, and 3. And hopefully at this point, you're getting better at kind of recognizing what an LCD is going to be without having to do a ton of work. And if you can get to that point, that's really, really great. If not, we can still work some stuff out here. So let's see if we can figure out what the LCD is. So we're just going to list out multiples. So looking at 2, I want 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. And 2 times 6 is 12. I think 12 looks good, but let's just prove that it's going to work for all the other numbers. So 3 times 1 is 3. Times 2 is 6. Times 3 is 9. Times 4 is 12. So that's good. Let's look at 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. So 12 is looking great so far. Let's make sure it works for 6. 6 times 1 is 6. 6 times 2 is 12. So we can see 12 is the smallest multiple all of these denominators have in common. So the LCD is 12. So here's what you do. You multiply the numerator and denominator by 12. And I take it one step further. I multiply each interior fraction by 12. That way I don't have to worry about distributing. So what this is going to look like is I'm going to take 12 and I'm going to multiply it by 1/2 plus 12 times 1/6 all over 12 times 3/4 minus 12 times 2/3. So essentially what I've done here is I've multiplied the numerator and denominator by 12. I just went ahead and showed where I distributed. Okay. And now something really, really cool happens. We need to do a little division. So looking at this 1/2 times 12, this denominator of 2 will divide into 12 6 times, and I'm left with just 6 times 1, which is 6. I would much rather deal with a 6 than a 1/2. Looking at the second half of the numerator, the denominator of 6 divides into the 12, the LCD, twice, leaving me with just 2 times 1. So now my numerator went from 1/2 plus 1/6 to now just 6 plus 2, which is a heck of a lot easier to deal with. Now let's look at the denominator. The first half of the denominator have 3/4 times 12. Well, the denominator of 4 divides into the 12 3 times, leaving me with just 3 times 3. So my denominator is now a 12. And then looking at the last half of the denominator, I have 2/3 times 12. Well, the 3 2/3 divides into the LCD of 12 4 times, leaving me with minus 4 times 2. Well, 4 times 2 is just 8. So let's see what this all looks like. So the numerator is 6 plus 2, which is 8. The denominator is 9 minus 8, which is 1. And this all really just simplifies to 8. So the other way we could have done this is we could have added 1/2 and 1/6 which is fine. We know how to do that. We then could have subtracted 3/4 and 2/3, which again, it's a lengthy process, but we know how to do it. And then at the end, taken whatever we got for the numerator and divided it by whatever we got for the denominator. It would have been an intense three-part process, but by doing this, it just kind of shortened the work for us a bit. Okay? So let's look and do the same thing for part B. So part B is actually going to be a bit quicker. We have 3/4 as the numerator, and then the denominator is 3/5 minus 1. So let's go ahead and look at those interior denominators. We have 5 and we have 4. So if we were to list out multiples, 4 times 1 is 4, times 2 is 8, times 3 is 12, times 4 is 16, times 5 is 20. Again, hopefully you're getting one, better at your multiplication tables, and two, better at seeing what some of these LCDs are. I hope you're at home kind of like knowing what the LCD is going to be. But if not, we'll keep listing out multiples. Whoops. So now let's list out multiples of 5. 5 times 1 is 5, times 2 is 10, times 3 is 15, times 4 is 20. So we see a common multiple that tells me the LCD is 20. Okay? So let's rewrite this. For my numerator, I'm going to take the LCD of 20 and multiply it by 3/4. For the denominator, I'm going to take 20 and multiply it by 3/5. And I still, even though 1 is not a fraction, it still must be multiplied by the LCD. Otherwise, we're not multiplying all parts. So we're technically multiplying the numerator and the denominator, but when I multiply the denominator, I have to distribute it through. So both parts of the denominator have to get multiplied by the LCD. So I get minus 20 times 1. So let's clean things up. Looking at the numerator, the 4 in the denominator divides into the 20 5 times, leaving me with 5 times 3 in the numerator, which is just 15. In the first half of the denominator, the 5 and 3/5 divides into the LCD 4 times, leaving me with 4 times 3, which is 12. And then finally, we have negative 20 times 1. Well, negative 20 times 1 is just negative 20. So let's clean it up. The numerator is just 15, and then the denominator, we have 12 minus 20. And if you need to do side work for that, that is fine. So if we have 12 minus 20, remember, we can rewrite that as addition. So the 12 stays the same. And then I add the opposite of positive 20, which is negative 20. So we're adding numbers that have different signs here. We want to find the difference in the positive and the negative, so we subtract. 20 minus 12 is 8, but it happens to be negative here because I have more negative than I do positive. So this is negative 8. So that means my denominator is negative 8, which just makes this whole thing negative 15/8. So there you have it. Again, you're not going to do a whole lot with complex fractions, but I wanted to at least show you what a complex fraction is and a shortcut for simplifying them.